we also need to know some basic trig and exponential in antiderivatives because, and again, we're not going to generate those, but we just need to know them because if we know the derivative, we should know the antiderivative. So the derivative of cos is negative sine, so the antiderivative of sine is negative cos. The derivative of sine is cos, so the antiderivative of cos is going to be sine. Okay, so these are just, if we know the derivative, we should know the antiderivative. We could also write in here, if we differentiate tan, we end up with secant squared. So the secant squared, the derivative, is written as an integral like this. I want the antiderivative of that. Well, that means I must have started with a tan x plus c. Okay, and we can account for our horizontal compression expansions as well, right? Before we times when we differentiate, now we're going to divide by those when we integrate. Same thing here, the derivative of e to the x is e to the x, so the antiderivative is e to the x, and we need to account for that plus c. If we differentiate log, we get 1 over x. If we anti-differentiate 1 over x, we get log absolute value plus c. Now the reason why that absolute value is there is because the domain of this function, so the domain of this function is from negative infinity to 0 and from 0 to positive infinity. Okay, so that's the domain of this function. When we anti-differentiate, we need to make sure that we are keeping the same domain so we can still use the same x's that we used over here in here. So the domain of that new function has to stay the same. Okay, so this domain has to apply here and also here. Now without the absolute value, we cannot use this part. We can't use negatives in logs. So without the absolute value, we can't use this part. So that's why we put the absolute value in there, so that the domain of the original function matches the domain of the antiderivative function. Okay, so let's just apply some of these. So if I have a differential equation, what's implied is I want to solve for y. Okay, or I want to, in other words, find the antiderivative. So if I have dy by dx here, what I really want to do is just find y, or anti-differentiate. So I get y is equal to, for x to the power, I increase the power by 1, I divide by that to account for that coefficient, and then I need a plus c. Okay, so there's my general equation. So it looks like this: 1/2 x to the 8 plus c. Okay, now I'm just going to show you, this is kind of a preview of what we're going to end up doing, but really what we're actually doing, okay, is we can actually relate this to area. Okay, although I've said that this is the anti, we're just undifferentiating, we're just doing the opposite of derivatives, we can actually find area here. And I'm going to do it like this. I'm going to go dy is equal to 4x, and I'm just going to move the dx from the bottom times to here. And this really means the derivative height times the width dx equals a change in the original y function, or the antiderivative function, and we can sum up those changes like that. And when we sum it up, now this is a little bit of a stretch. Now this isn't really, it's not technically true, but we can say that the sum of all the dy's equals y. Okay, it's actually not quite true, but we can kind of frame it like that, and then we can say that then the sum of that is the antiderivative for x 8 over 8, and then we need a plus c because it was an indefinite integral. Now this isn't quite true that we can just sum up like this, but it's essentially true. Okay. Now some of you may say, well, what's the big deal? I don't really see the big deal, or why it couldn't be true. Well, that's fine because this is essentially true, but there is a little bit of a gap in it if you actually dig a little bit deeper, but that's not a big deal. So we can just do this, okay, and we get the same. We end up with the same result. Now, we don't really need to know the green right now. We'll learn that a little bit later. But this is kind of essentially what we're doing. And if you want to understand how the area relates to it, we can kind of relate it this way. Okay,